Hello again. Today we will go to the most important part of the API that it predict something and find the logic and save the logic. Okay. The data sets we're going to test our API today is non-trivial data sets from California Irvine. Okay, it is breast cancer Wilkinson. Okay, you can see the data set is multivariable and the number of instance is 569 instance and number of attribute about 32. It is donated in 1995 and the feature are computed from digitized image of a fine needle aspirate of breast mass. They describe the characteristics of the cell nuclei present in the image. Okay, you can see that they have sample ID diagnosis like M malignant and B benign. They have radius, texture, perimeter, area, smoothness, and so on. Okay, the data file you can find over here. Okay, and let's talk about limited data set. Okay. The data set, the creator is Dr. William Wolbert, General Surgery Department, and W. Nick, and so on. Okay, they donor by Nick Juice. Uh, okay, uh, we predict two few diagnosed B and benign. Okay, or M malignant. Okay. Oh, we also have missing attribute value. Okay. Here the data folder. Okay. Okay, I save it on a CSV file with like this: sample number, thickness, cell size, cell shape, okay, adhesion, uh, epic cell size, hair, and classes. Classes is benign or malignant. Okay. Okay. You also notice that we have some missing data over here. Okay, and let's do it. Okay, now let's start it. Okay, I have saved the CSV file on my data right here. So as always, we have to load, you know, uh, the the API, so it have all the function that available to you to run on that specific data. Okay. Like I talked previously, you see that we have question mark, right? We have question mark on the data. That's not good at all, when you have not unified data type, it will not show you anything. That's why you have to somehow remove or replace it with something else. In this one, I can replace it with column median, okay? Okay, basically the median in bare nuclei is 1. So I replace all of 16 of the question mark missing data by median. Okay, or you can also replace uh, with mean. Okay, the bare nuclei they have the missing data. Instead of you replace it with the mean, you can replace with the median. Excuse me, you can replace with the mean. Okay. Let me talk about a little bit about interaction of this one. So basically, in order to extract data or extract logic, we need the X data and the Y. The X is I select only 1 to -1 because I want to avoid ID and classes. I don't want it included into my prediction data. And the Y I use here the target. The target is class. Class is either the numeric representative of malignant or benign. Malignant is 1, benign is 0. Okay. In other datasets we have, you can use it like diabetes uh, or food allergy or IBD, anything. And uh, and this is one of the so we separate into 3 parts. The first part is feature reduction. So you see here target here. Feature reduction, they use X and Y, you know, to we use X and Y to calculate forward and reverse and chi-square and many different technique to reduce just only select the significant attribute, because sometimes like my data you can see the attribute can up to 600 different attribute. Okay, you need the best tool to find the best attribute that you're looking for. So let's try with select K-best, right? Basically, K-best is the use chi-square to find the best 5 attribute that will be good to use. So if you select 6, we go 6, right? You select 4, we go 4, okay, and so on. If you also use laser, because laser sometimes with very huge in some data set we have huge attribute. Laser is so very helpful. In this case, laser find that on of 9/9 attribute is very good to use. Is good to use. Okay, or you can even use the tree reduction. Okay, the tree is basically they batching, and by batching they found that just only 2 is really 3 don't really matter over here. Okay, and the random logic regression base is very good one. It's fast and it's very good one. It found that 9/8 is a good one. Okay, you also can use cross validation. Okay, basically cross validation is uh, oh cross validation you also need to get the check CV. Okay, cross validation is also known as K4 CV. They the training set the number of training set that is split, you know, into K smaller set. To the more set you separate, the more accurate. You know, you basically you separate to the training set to test to select the best attribute. So let's try it. If you select into 3, okay, you see that it took so long. I recommend that you just use maximum of 3, or you only use in small datasets with less than 100 instances. Okay. Okay. Now let's try the CRF method. Okay. With 7/9 good attribute, we have the accuracy of 98%. Okay. The reason this method takes a little bit long because it have to to look to find the best C and grammar in that data set. Okay. Okay. How about if you don't use any reduce attribute, none of it, you say XE untouched. Okay. And if you pick like random forest, okay, if we say okay, it very good in predict that you are not diseased, but when you have the disease, it show that not very good because just only 92%, even though you don't have disease, but it's how you have the disease, so it's not really good. Um, so basically, the way it is it separate, it split the dataset into training and testing datasets. Okay, you can see it here. Um, okay, in this case, it separate 35% of the data and for training and 25% for testing. You can see it here, and the number of disease is 300. The number of non-disease is around 186. Okay, and so on this one. The reason is separate into the training and testing because it tries to avoid bias. In this one, you see the training score is very high, but the testing score in the real life testing, it not show a lot of inaccuracy over here. So I recommend that this is good practice because you need to separate into the training and testing to avoid bias for your prediction. Uh, okay, let's try to select into 9A. You see that when you filter your attribute, okay, just select the best A of it, and you see the accuracy does improve a lot. Okay, 97 instead of 89. And you also noted that okay, let's try this one. Yeah. You also noted that we have the safe logic area over here. Okay. So the reason that I save the logic because everything here is random. Okay. In some random interaction, you may find something really good. Okay, and you don't want to miss it. Okay. Whenever it's done over here, say logic was successfully saved. So that's why I save it for later use. You don't need to do all of this again. You just use your save logic to predict. In this one, I save my logic uh, over here. I save the feature that I use for prediction and as well the logic prediction that I extract from interaction. I save with different name so it's not overload with different logic. And we have the function called predict using recall logic, to find out on to get on the prediction from the x value. In this one, it run data. Then you check you set y a classes, okay, and then you check accuracy between y and predict data. Okay, you can see that in when interaction with the data, I uh, I I accidentally, you can say that, found that the logic is really good. It can run up to 99% accuracy in predict between malignant and benign cancer. It awesome. So the reason that the prediction is so good because the person that donate the data, he knows so well about the disease. That's he knows so well, he has so much experience. That's why he give us very informative attribute and data. The same with in the future of this application, you should learn your disease really well, okay, in order to get a very good prediction and extract a very good accuracy. So now you can see that breast cancer can be predicted up to 99%. So if you want to double check your your prediction, you want to help, I share with you the file, the log file for this prediction, so you can predict your patient cancer, okay. And I have many more, you know. Believe looking for more video on the next one. We have many more to give. All right, that's it for today. Thank you so much for watching. Yeah.